If you are watching this video for the first time, make sure you are subscribing to Anantha Lakshmi Academy. Once you click on the subscribe button, you will see a bell icon. If you click on that bell and click on all, you will get to know whenever I upload a video. This will send you a notification. Hello everyone, welcome back to Anantha Lakshmi Academy. As told in the earlier video, I am ready with exercise 3.3 problems already listed on the board. If you are directly coming to this video, there is a video already uploaded with the concept that is needed for this. Please go through that even before this. If you are not able to figure that out, I'll be attaching the playlist of polynomials in the end card. Playlist is nothing but it has all the videos of polynomials so that you could go through it. Alright, so let's get started with exercise problems without any delay. So let's go to the first problem. Find the zeros of the polynomial and verify the relation between zeros and coefficients. So how do we figure out the zeros? By equating this to 0. That is, for some value of this equation, when it is substituted, this is going to be equal to 0. So this is nothing but 4s square minus 4s plus 1. So this is going to be 4s square minus 2s plus 1 is equal to 0. When you take out the 2s common, this is going to be like this. Alright, what are the roots? 2s minus 1 is equal to 2s minus 1. That is nothing but s is equal to 1 by 2 comma 1 by 2. Now that we got the zeros, how do we figure out the relation between zeros? Zeros and coefficients is nothing but alpha plus beta is equal to minus b by a. What is minus b by a? Minus b by a is minus 4 by 4, which is equal to 1. When you substitute alpha and beta, alpha plus beta is equal to 1 by 2 plus 1 by 2 is also equal to 1. Hence, both of them are equal, isn't it? Then, alpha beta is equal to 1 by 2 multiplied with 1 by 2 is 1 by 4. But as per the concept that we have learnt, alpha beta is equal to C by A is equal to 1 by 2 by 1 by 2. Alright, C by A, C is 1 and this is A is 4, which is nothing but 1 by 4. So what have we done here? We have extracted the zeros of the polynomial first. Then we figured out alpha plus beta according to the concept that we have learned, and actual alpha plus beta by doing the sum of the zeros which we have extracted. Alright, that is about second bit in the problem number 1. Let's jump into the next one, which is 6x square minus 7x minus 3 is equal to 0. How do we get zeros of this? This is 6 3s are 18. 2 9s is also 18, right? So let's try figuring out. 6x square minus 9x plus 2x minus 3 is equal to 0. Which is, if I take 3x common, 2x minus 3 plus 1 into 2x minus 3. So this becomes 2x minus 3 into 3x plus 1 is equal to 0. So x is equal to 3 by 2 comma minus 1 by 3. Now that we got the zeros, can you figure out the relation? Like alpha plus beta is nothing but, what is it? Minus b by a. 3 by 6, which is 1 by 2. 3 by 2 minus 1 by 3, if you do the addition part also, you are going to get the same. I am leaving this part of the alpha plus beta and alpha beta to you guys so that you solve on your own and try figuring this out. If you do not get it, please ping in the comment section asking me to solve it. I'll be doing it in the later videos. Alright, so let's jump into the fourth bit. Here within the first question, I have taken the ones which are a bit different from rest of the things. Alright, so this is quite simple, so I am leaving the simplification part of alpha plus beta and alpha beta to you guys. But if you look at this, 4u square plus 8u, here you do not have a constant, so this can be written as 4u into u plus 2 is equal to 0. This indicates that u is equal to 0 or minus 2, isn't it? So alpha plus beta is equal to minus b by a is equal to minus 8 by 4 is equal to minus 2. What is our alpha and beta? 0 and minus 2 kada. 0 minus 2 is equal to minus 2. So when we verifying with the problem and with the concept, both of them should be equal. So alpha beta is equal to, what is it? C by a. C by a is nothing but 0 by 4 is nothing but 0. Then alpha and beta, whatever the values we have got, 0 multiplied with anything is 0, isn't it? So now here the fifth one, if you look at here, t square minus 15 is equal to 0. So t square is equal to 15, which implies t is equal to, when you remove this square from this side, it becomes the root of 15. So t is plus or minus root 15. So alpha is, if you assume alpha is root 15 and beta is minus root 15. So let us solve the relation. Alpha plus beta is equal to root 15 minus root 15 is equal to 0. This is the summation of these two. Then we have the concept alpha plus beta is equal to minus b by a. What is minus b by a? You do not have t term here. So that is minus 0 by 1 is nothing but 0. Now alpha beta is equal to root 15 multiplied with minus root 15 is nothing but minus 15, isn't it? Now alpha beta is equal to c by a. What is c? Minus 15 and a is 1. So that is about first problem, wherein we have extracted the zeros and we solved ourselves like alpha plus beta according to the concept and alpha plus beta by really doing the sum and product of the zeros. So when we verified the relation, both of them should be equal and they are equal. Alright. So let's jump into the next problem, the second problem, wherein they are asking us to find the quadratic polynomial where sum and product of its zeros are given. Alright. So alpha plus beta is equal to minus b by a. Here it is given as 1 by 4. So if I assume b, so if from this statement what can I make out? A is equal to 4. What is b? B is 1 here. It is minus b by a. So b should be minus 1, isn't it? Then alpha beta is equal to minus 1, which is nothing but c by a is equal to minus 1. Now we already know that a is 1 by 4. If there is 1 by 4 existing here, in order to get minus 1, what should be there in the value of c? C should also be equal to minus 1 by 4, isn't it? Now that we got to know the value of a here. Okay, let me so c by a, right? This is alpha beta is equal to c by a is equal to minus 1, which indicates that we have already got 4 here. What should be the c value such that c by a becomes minus 1? Nothing but minus 4, right? C is equal to minus 4. Now that you know a, b and c, what is the expression? Ax square plus bx plus c, which is nothing but 4x square minus x minus 4. Simple, isn't it? First of all, we need to figure out what is b and a from alpha plus beta. Now that you know the value of a, you need to figure out c from alpha beta and finally substitute in the quadratic polynomial ax square plus bx plus c. Alright, let's look at the next problem. The bit number 2, alpha plus beta is equal to b by a, right? Minus b by a is equal to root 2. If you look at this, we get to understand that the denominator is 1. Hence, a is equal to 1. minus b is equal to root 2. What is b then? B is nothing but minus root 2. Alright, then alpha beta is equal to c by a. We know that a is already 1 and you have c as 1 by 3 by 1, isn't it? So c, what is c? Is equal to 1 by 3. Now that you know a, b and c, can you write the quadratic equation? Yes. Ax square plus bx plus c is equal to x square minus root 2x plus 1 by 3. C is nothing but 1 by 3. Alright. If you want to take this here, it becomes 3x square minus 3 root 2x plus 1, or else you can leave this over here. That is also fine. Okay. That's about bit number 2. Let's jump into the third interesting problem, wherein sum is given as 0 and product is given as root 5. So alpha plus beta is equal to 0. 0 is nothing but our minus b by a is equal to 0. When would a fraction be 0? When the numerator is 0. Alright. So here a is equal to 1 and b is equal to 0. Alpha beta is given as c by a is given as root 5. We already know that a is 1 from here. So c is equal to root 5. Now you know a, b, c. Can we write the quadratic polynomial? Ax square plus bx plus c is equal to x square plus 0 into x plus root 5. This is nothing but x square plus root 5. So that's about problem number 2. In the problem number 1, we have figured out the zeros and verified the relation. In problem number 2, given the sum and product of the zeros, we figured out the quadratic polynomial. Alright, so let's jump into problem number 3. Here we are ready with the third problem, wherein they are asking us to find the quadratic polynomial where alpha comma beta are given in each case. So if you have already gone through the concept, you will understand that when we assumed alpha and beta being the constants, how the expression was x square minus alpha plus beta into x plus alpha beta, right? So here, since the zeros, alpha and beta are given, we will be considering the sum of the zeros first, next product of the zeros, and then we will be substituting that in the equation and getting the quadratic polynomial. So let's solve that part first. So alpha is equal to root 3, beta is equal to minus root 3. Alpha plus beta is equal to root 3 minus root 3, which is 0. Alpha beta is equal to root 3 multiplied with root 3, which is nothing but 3. So when we were discussing about the concept, we thought ax square plus bx plus c is nothing but is equal to k into, how did we do it? Ax square plus bx plus c is equal to k into x square minus alpha plus beta into x plus alpha beta. Now that you know alpha plus beta and alpha beta, can we substitute in the values? Yes, which is x square minus 0 into x plus 3, which becomes k into x square minus x square plus 3. But can we write any polynomial just in case of k? No, right? So when k is equal to 1, what does this become? The polynomial, the quadratic polynomial is nothing but x square plus 3. So the answer is x square plus 3. Now here, in the third bit, one of the zeros is a fraction. So let me write it as alpha is equal to 1 by 4, beta is equal to minus 1, alpha plus beta is equal to 1 by 4 minus 1 is equal to minus 3 by 4. Alright, next, alpha beta is equal to 1 by 4 into minus 1, which is minus 1 by 4. How did I get minus 3 by 4? I took the LCM. 1 minus 4 is minus 3 by 4. Alright, and then alpha beta is just the multiplication part, and we got this. Now let us substitute in the equation, quadratic equation. How did we get it? Ax square plus bx plus c is equal to k into x square minus alpha plus beta into x plus alpha beta. Now that you know the values of alpha plus beta and alpha beta, let's substitute them. K into what is x square minus 3 by 4 multiplied with x and minus 1 by 4. So what is this going to be? K into x square minus 3 by 4x plus minus 1 by 4. So let me consider the LCM. K by 4 into 4x square minus 3x minus 1. And the solution cannot be in the form of k. So when k is equal to 4, when k is 4, solution is 4x square minus 3x minus 1. So what are we trying to do? In every problem there will be a constant associated with. We have to make sure for some value of k, for whatever the value that we are getting the quadratic equation, we need to make sure the fraction or the multiplication with k becomes 1. If there is just k, we assume k as 1. If there is k by 4, you need to assume k such that this fraction becomes 1. So what is the value for which k by 4 becomes 1? 4. So I assume the value of 4 and then 4x square minus 3x minus 1. So that's the solution for the third bit. So here you have to ensure that you are having k, and for whatever the means, we have to make sure that the fraction or the multiplication with k becomes 1. Only then our solution matches, and you cannot put a solution which is multiplied with k as the result. Okay, so you need to make sure this is going to be 1. Alright, let's jump into the last problem of the exercise, wherein they are asking us verify 1, minus 1 and 3 are zeros of a cubic polynomial. They have given a cubic polynomial. What is a cubic polynomial? Which has a degree of 3. And check the relation between zeros and coefficients. Alright, so let's get started. Let p of x is equal to x cube minus 3x square minus x plus 3. Alright, now they said 1, minus 1 and 3 are the zeros. What are zeros? When we substitute those values in the polynomial, we get the result as zeros. So let me do p of 1. 1 cube minus 3 into 1 square minus 1 plus 3. That is 1 minus 3 minus 1 plus 3 is equal to 0. All the terms gets cancelled. P of minus 1. Minus 1 whole cube minus 3 into minus 1 whole square minus of minus 1 plus 3 is equal to minus 1 minus 3 plus 1 and plus 3. Now also 3 minus 3, 1 minus 1 gets cancelled, 0. Next is P of 3. 3 cube minus 3 into 3 square minus 3 plus 3, which is 27 minus 27 minus 3 plus 3. Again 3 and plus 27 minus 27 are getting cancelled. So when you substitute the value of 1, minus 1 and 3 in the polynomial, what is the result that we are getting? 0. Hence 1, minus 1 and 3 are the zeros of a polynomial. So let us write the statement. When we substitute minus 1 and 3, p of x is equal to 0. Hence they are zeros. Hence 1, minus 1, 3 are zeros of p of x. Isn't it? That's what is the concept we have learned, right? So next thing, what are they asking us? Check the relation between zeros and coefficients. So what is the relation between zeros and coefficients for a cubic polynomial? Alpha plus beta plus gamma is equal to what? Minus b by a, which is nothing but, what is b here? Minus 3 and a is 1. isn't it? So this becomes 3. So let us try figuring out alpha plus beta plus gamma is equal to 1 minus 1 plus 3, which is also equal to 3. So now that the value which we got by adding up the zeros and the value when we substitute it are same, verified. Now let's do it for alpha beta plus beta gamma plus gamma alpha. Product of the roots multiplied 2 at a time is nothing but c by a. What is c? Minus 1 by 1 is nothing but minus 1. So alpha beta plus beta gamma plus gamma alpha is 1 multiplied with minus 1 plus minus 1 multiplied with 3 plus 3 multiplied with 1, which is nothing but minus 1 minus 3 plus 3. 3 and minus 3 gets cancelled and the answer is minus 1. So the result which we got from the formula and by substituting the values of the zeros is equal. This is also verified. Alpha, beta, gamma, what is the formula? Minus d by a. What is d here? 3. Minus 3 by 1 is nothing but minus 3. Now let us substitute alpha, beta, gamma values. 1 into minus 1 into 3, which is nothing but minus 3. So when they said you need to verify these are zeros by substituting those values, we should get 0. Only then we call them as zeros. We verified that part. And relation between zeros and coefficients they are asking us to find. So one thing is you can just substitute them in the formulas and leave it. Since I have explained you the concept, I also showed you that by substituting the alpha, beta, gamma values, you should get the same result as in when you are substituting in the formula. That is the reason I have shown this to you guys. Alright, so that is about exercise 3.3 in polynomials. So if you like the content and you are able to solve the problems by listening to these things, well and good. So please do like, share and subscribe to Anantha Lakshmi Academy. Also publish it to your classmates, share it with them or any of your relations who are studying 10th class. So this is it for this video. In the next video, I'll be discussing we will be exploring more on exercise 3.4, the concept of division of polynomials. Alright, till then keep watching Anantha Lakshmi Academy. Thank you for watching.